Hi guys, I want to go over your page 99 to 100 that you had last week. I got a lot of questions on it. I helped a lot of students with it. And even if you totally got it, I want you to still watch this video while you're looking at your work and the actual word problems. The things that we're going to focus on in this video are keywords that kind of guide us into knowing what to do with the numbers, okay? Uh, there were other sections where it said we're multiplying, we're dividing, we're adding, we're subtracting. This is that first section that was kind of like, we're not going to tell you what you're doing. You're going to do multiple steps. So the only thing you really know is it's not a one-step problem. So I'm on page 99. I'm going to just go through 3 through 9. If you have not done this assignment yet, you need to read each word problem before I start talking, because I'm not going to read each word problem to you. I'm doing this video under the assumption that you've already read them. Okay? So page 99, number 3. So Carl is walking, okay? And he is walking 3 1/4 mile his first day. And then he's walking 5.5 miles his second day. Okay? A lot of these problems, you have to add the two first numbers. It's kind of like that problem where we had lentils. So we had a certain amount and then we had a little bit more and we had to figure out how many we had in total. So he walks a little bit and then he walks a little bit more, and now we need to figure out how many he walks in total. So the first thing I'm going to do is add these. To add these, I have to make improper fractions, get common denominators, add the top number, keep the bottom number. Rewind that if you need to. Okay, so improper fraction, 3 times 4 plus 1, 12, 13, keep the denominator. 5 times 2, 10, plus 1, 11 over 2. Now, what I like to do is rewrite both fractions immediately with that common denominator I know that I'm going to work with. Then this one was a 4, so I get to keep the 13. And this one I multiplied by 2, so I multiplied by 2 here and I get 22. I add the top numbers and I keep the bottom number. Now, you are not going to turn this back into a mixed number because we have to do more things with it. And if we have to do another step with it, it's going to have to go right back into improper fraction anyways. So please do not change that. On your paper, don't erase, but I'm going to. So I'm going to remember 35 over 4. 35 over 4. So he walked 35 over 4 miles. Now, his parents gave him $175 because they donated each mile he walks. So I want to know how much money they gave him for 1 mile. So I'm not going to divide this by 175. I'm going to do 175 divided by 35 over 4. No, I'm going to do 35. It's the same math. Okay. So I'm really going to do 175 over 1 times 4 over 35. Sorry. It is hard to decide which order to divide in. As you can see, my brain's going because it is very difficult. So what I do sometimes, and I did this with a student earlier because we were both like, wait, which order do we do this in? Think about it like this. If my parents were going to give me $20 and I walked 10 miles, how much do they give me per mile? So we kind of, because we picked numbers that we know it's $2 per mile. So am I doing 10, the number of miles, divided by 20, or 20 divided by 10? 20 divided by 10. Money divided by miles. Okay? So if it becomes really difficult, like you just saw me with my brain, like, wait, am I doing it the right order? If it's hard, pick numbers that you do know. Make the same scenario and pick easy numbers. And then ask yourself, which order makes the most sense to divide in? Okay, and if you do that, you'll almost always find that answer. Because even earlier when I was working with that student, we both were like, oh, money divided by miles. Okay? So, money, $175. I made it over 1 divided by miles. I flipped it and made it multiplication. I really want to use some cross canceling. Now, I only see a 5 in both of these. So I'm going to start by dividing them by 5. So 35 divided by 5 is 7. 175 divided by 5 is 35. And then I see that 7 and 35 also have something in common, so I just do this twice. It's no big deal to do it twice. So 7 goes into itself once and into 35 5 times. I gather up what's left and I multiply straight across. 5 times 4 is 20. 1 times 1 is 1. So they gave him $20 per mile. Now, on the off chance that you ended up with 1 over 20, you just need to ask yourself, does that make sense? Did they give me 1/20th of a dollar per mile? No. And so when you find yourself with a number that doesn't make sense, this is what you need to reverse, the order you divide it in. Okay, so hopefully that makes it a little bit more clear. Let's look at a few more problems. All right, number 42. Number 4. An art teacher has 1.5 pounds of red clay and 3/4 pounds of yellow clay. So we're going to first figure out how much clay this teacher has in total. So 1 times 2 is 2 plus 1 is 3. Plus 3/4. We need common denominators of 4. So this one I didn't have to change, but this one I multiplied by 2, so I'm going to multiply the top by 2 and get 6. I'm going to add the top numbers and keep the bottom number. So this teacher has 9/4 pounds of clay. So you don't erase, but I'm going to. So they have 9/4 pounds of clay. Now, every student needs 1/8 pound. So I want to know how many 1/8 go into 9/4. So that means 9/4 divided by 1 over 8, which is really 9/4 times 8 over 1. I'm going to cross cancel. 4 goes into itself once. It goes into 8 twice. I gather up what's left and I multiply across. 9 times 2 is 18. So 18 students can do this art project. Okay, so because I was putting the 1/8 into 9/4, it's 9/4 divided by 1/8. So if you know one thing is going into the other thing, this comes first and that thing going in goes second. Okay, because this is really all about the order. When we did multiplication, the order doesn't matter, so it's not as complicated. All right, let's look at a couple more. And I'm just going to do them until I see my time run out on my video, okay? So let's look at another one. A hairstylist schedules 1/4 an hour to trim hair and then 1/6 of an hour to style the hair. So we want to know how much altogether it takes this hairstylist to work with one client. So we need to get common denominators, and I see a 12. So 6 times 2 is 12, so 1 times 2. 4 times 3 is 12, so 1 times 3. So this gives me 5/12. All right, so that's how long the hairstylist needs for one client. Now, we got 2 other numbers in this problem, so we're going to have to figure out what's going on. So she plans to work 3 1/3 hours each day for 5 days. Each day. Yes, that's multiplication. So she's going to work 3 1/3 hours for 5 days. So I need to make this an improper fraction. 3 times 3 is 9, plus 1 is 10/3, times 5 over 1. So 50/3. This is the amount of time she has in the week. This is the amount of time she needs per person. So we want to know how many of these go into those. So hopefully you already know we're doing 50 over 3 divided by 5 over 12. And I'm going to erase all this. You don't erase, okay? So I'm really doing 50 over 3 times 12 over 5. I really want to